1. Routing of wire harnesses. 2. How to read electrical wiring diagrams. 3. How to use EWDs. And 4. Repairing wire harnesses and terminals. Here are all the wire harnesses used in a single vehicle. Let's look now at the individual harnesses. First of all, looking from the front of the car, there is the engine room main wire harness. This wire harness is connected to the headlights, clearance lights, and turn signals, among others. Located in the center of the engine compartment is the engine wire harness. This connects the electrical parts of the engine with the engine ECU. Located under the cowl panel is the cowl wire harness. This harness runs from the left cowl to the right cowl. And hooks up to the combination meter and air conditioner control assembly. The instrument panel wire harness runs from the left cowl to the right cowl, parallel with the cowl wire harness. This wire harness branches out from the center to the center console box. The floor wire harness passes from the right and left cowls to the right and left sides of the floor. Branching out from these harnesses are the door wire harness and the luggage room wire harness. The door wire harness connects up in each door with the power window switches and the electrical door lock components. The luggage room wire harness goes to the rear combination lights and the license plate lights. Now we have looked at the main wire harnesses inside the car. Where and how are these wire harnesses connected with the other wire harnesses? Junction blocks and harness-to-harness connectors are used for these connections. The most important areas to notice are in the engine compartment and in the left and right kick panels. First of all, let's examine the engine compartment. The engine room main wire harness, engine wire harness, and cowl wire harness are connected by junction block number 2. In junction block number 2, relays such as the headlight relay and engine main relay, as well as the fusible links and the fuses, are installed. These supply the heavy current from the battery to the individual wire harnesses. Now we look at the kick panel on the driver's side. Here, the cowl wire harness, instrument panel wire harness, floor wire harness number 1, and front door wire harness are connected by junction block number 1, or with each other via harness-to-harness connectors in the vicinity of junction block number 1. In junction block number 1, the fuses and relays are installed in the same way as with junction block number 2. As is true for the cowl side on the passenger side, the individual wire harnesses are joined by connectors. Understanding the routing and connection locations of wire harnesses is extremely important when troubleshooting problems in the electrical system. Make sure you have a sufficient understanding of these items. Toyota issues EWDs for all models. Correctly and effectively using these EWDs will greatly assist you in troubleshooting. For this, it is important to understand the correct and effective way of using the EWD. We will use the latest EWD for the 1991 Camry to study the procedure. First, there is the introduction, in which the entire contents of the EWD are described briefly. Next is the section called How to Use. Here is where the real learning starts. This is followed by troubleshooting, which includes a description of the basic procedures for checking voltage and resistance. Also found here are procedures for disconnecting connectors and removing terminals. Study in detail the repair of wire harnesses shown in this video for the correct terminal removing procedure. This section is a description of the terms and symbols used in the wiring diagrams. There were originally 2 symbols for fuses and fusible links. However, as can be seen in more recent EWDs, there are now 3 of them for 3 capacity ranges. This symbol is also relatively new. It shows a splice point in a wire harness. Although there was originally only this symbol, by inserting a letter into the octagon, it is now possible to show the location of the splice point also. The next section is on relay locations. Here are the locations for the relays, junction blocks, and relay blocks used in the car. Also shown here are the locations of the relays and connectors in the junction blocks, and the internal circuitry of the junction blocks. The section called Electrical Wire Routing shows the locations of the wire harness connectors that are connected to the individual parts. This symbol is the code for this connector. The name of the connected part is written in the lower column. The first letter in the code is the first letter of the part name. For example, A9 refers to the right front ABS speed sensor, and B1 refers to the backup light switch. The harness-to-harness connectors are indicated by a rectangle, and the grounding points are indicated by an inverted triangle. The splice points explained earlier are indicated with an octagon to show their locations. With harness-to-harness connectors, the configuration and color are also displayed. The letter at the beginning of each symbol indicates the position in the car. For example, I indicates the instrument panel, E indicates the engine compartment, and B indicates the body. The section on power sources shows the connections for all power sources. For example, the systems for which this 30 amp AM2 fuse acts as the power source are the following. Or, if we want to know what systems the individual fuses act as power sources for, we can consult this chart. For example, if a 20-amp dome fuse blows, we know this will affect these systems. Next are the various system circuits. Since we will look at these in detail later on, let's go on to the next section. The section on the grounding points also shows all ground wires, so you can see at a glance which systems share the same grounding. Finally, there is the overall electrical wiring diagram. With this, it is possible to see the connections from the power sources to the actuators and sensors for each system. Now let's return to the table of contents for the circuitry for individual systems. For example, when we want to examine the headlight system, we turn to page 186. When we open to page 186, we see the system circuitry for the headlight system. This includes the daytime running lights for left-hand drive vehicles. As you can see, the system circuitry is listed on different pages, depending on the vehicle specifications, so you must consult the applicable page. The page following the system circuitry gives service hints, such as the operations of the relays and switches. The voltages of the terminals in a circuit are sometimes listed in the same service hints column. There are also cases where an outline of the system is given. This is because it is necessary to know the operation of the system for the purposes of troubleshooting. After service hints comes the location of the parts appearing in the system circuit, as well as information on relay blocks and splice points. Also listed here are connector configurations and terminal numbers. The number shown here is the terminal number. The black dot indicates a terminal that is not used with this system, but rather with another system. An X indicates that the position is empty. Let us now see how to read a system circuit diagram. In every system, the power source side is at the top, and the grounding point is at the bottom. Let's look at this in more detail. This is a fusible link. The number 2.0 indicates the area of the cross-section of the wire. L is the L from blue and indicates that the color of the wire is blue. The wires connecting the parts are indicated by their actual color as well as by letters of the alphabet. B indicates black. RL indicates blue lines on a red wire. The part shaded in black is a junction block. The oval indicates the connector connected to it. The number in the oval is the junction block number. The number to the side of the oval is the terminal number. In this case, for example, the wire harness from the fusible link is connected to the number 2 terminal of the connector for 2F of junction block number 2. When we want to find out the location of the number 2 terminal of 2F, we look at the reference page on the right. If we look at 2F, it shows engine wire harness and junction block number 2. If we look at page 56, there is a description of junction block number 2. 2F is at this position in the junction block. This is terminal number 2. Let's look at the location of junction block number 2. For junction block number 2, it is indicated that we should consult page 50 for the location in the engine compartment. Included on page 50 is the location of junction block number 2. This corresponds to this part. Let's return now to the headlight circuitry. Remember that this octagon indicates a splice point. It actually looks like this. The first letter is I. That means it's a splice point in a wire harness running behind the instrument panel. By looking at the reference page, we can get more detailed information on the location. Next, the items in blue indicate parts other than junction blocks. In other words, in the case of this circuit, it indicates the battery, relay block, bulbs, diodes, and combination switch. Numbers such as D3 or C11 indicate connectors for various parts. Also, the numbers written by the wires show the terminal numbers of the wires. Next, let's look at the relay block. As in the case of the junction block, the number in the oval indicates the relay block number. In this case, it is relay block number 5. Next, this symbol indicates a harness-to-harness connector. This arrow indicates a male terminal. In this case, the top is the male and the bottom is the female. If we look at the wire harness between the headlight relay and dimmer relay, we see that they are indicated with a red wire and a white wire. Refer to the notes in parentheses for an explanation of this. These two types of wire harness are never used with the same vehicle model. There are also a number of other rules that you must remember. For example, this is the inline fusible link that you saw before. This is also a fusible link. It is always shown inside a blue box. This type differs from the previous type because it is inserted in a case. 100 amps indicates the capacity and corresponds to the 2.0 type that we looked at before. This is the engine control system circuitry. If we look at the ECU terminals, we see that they are listed as A, B, and C. This is done in order to distinguish the connectors if 3 connectors are inserted in a single ECU, as is shown here. 22A is terminal number 22 of the E9 connector. 1B is terminal number 1 of the E7 connector. 7C is terminal number 7 of the E6 connector. This indicates a shielded wire used to prevent electrical noise. This is how it actually looks. The shield of the shielded wire should always be connected to the ground wire. This is the charging system circuit. This is known as a junction connector. Instead of producing a large number of splice points, it brings together the electrical currents from several wires by means of shorting pins in the connector. Up to now, we have been examining the procedure for reading the EWD. Hopefully, you have understood everything so far. Next, we will try using the EWD to carry out a simple troubleshooting exercise. On this vehicle, the left headlight fails to light. First, we check the problem in more detail. The left low beam does not light. If we look for the page on headlights in the table of contents for system circuits, we see that the circuitry for the applicable specifications is on page 190. Because the right high and low beams and the left high beam are all operating normally, their power source circuits and grounding circuits should also be normal. In other words, either the filament for the low beam has burned out, or there is an opening somewhere else in the circuit. First, we check whether there is battery voltage at terminal number 1 of the H1 connector. There is no battery voltage, even when changing to low beam. How about the fuse? The fuse is inside relay block number 5. If we look at relay block number 5 in the table on the next page, we are referred to page 62. The left low beam is connected to this fuse, and the location of relay block number 5 is shown on page 50. The fuse is in here. This is it. There is continuity, and the fuse is normal. Next, we check if there is battery voltage up to the fuse. In this case, terminal number 1 is on the power source side of the circuit. There is battery voltage. In other words, the brake must be somewhere in this circuit. Let's check the continuity in this circuit. Well, it looks like the terminal is not fully inserted. We insert the terminal. And then we check the headlight. Now it's operating normally. Let's go to the next example. If we shift into reverse, the backup lights, license plate lights, tail lights, and front clearance lights all light up dimly. If we return the shift lever to neutral and turn the light control switch to the tail position, the license plate light does not light. This is a rather complex problem. As this shows, when 2 or more lights light only dimly, we know that one cause is poor grounding. Let's investigate. First of all, we compare the circuits for the tail lights and the backup lights. They share grounding point BL and terminal number 4 of BB1 in common. Let's look now at the section on grounding points for more detailed information on the grounding circuits. The backup lights are included in these rear combination lights. If we look at the grounding, we see that it passes through B21, as well as B24 and BB1 to reach BL. The right and left license plate lights are also grounded via B24. In other words, the circuitry for both are actually as shown here. If BL is poorly grounded, and at the same time terminal number 7 of BA1 is disconnected, or if terminal number 4 of BB1 is disconnected, when we shift into reverse, the current flows to the backup lights, the license plate lights, and the left and right front clearance lights. The current also flows to the tail lights. Because these are all series circuits, the lights appear dim. If we now shift into neutral and turn the light control switch to the tail position, there is no grounding for the license plate lights, and the lights do not light. This is the problem we have been looking for. However, if BL and BA1 are both faulty at the same time, what about the other systems? Let's look at the grounding points. Because the fuel pump is also connected via this circuit, the engine will not start. This is different from the previous problem. That means there's a good chance this is not a case of a faulty BL and BA1, but rather a faulty connection in this section. Let's look carefully now at BB1. The location of BB1 is here. The male terminal is about to fall out. This seems to be the cause of the problem. Let's check it. Now it works all right. As we have just seen in the two examples, by making use of the EWD, it is possible to do a considerable amount of troubleshooting before even touching the car. If you first study the system circuitry and location charts to gain a sufficient understanding of the circuitry, you can keep work to a minimum, thus saving time and avoiding replacement of incorrect parts. This is the sign of a superior technician. We have already studied the correct procedure for using an EWD in troubleshooting. Now let's look at the correct procedure for carrying out repairs when the cause has been located. For this, there is the wire harness repair manual. This manual shows how to connect wires, how to remove terminals, and how to insert terminals. It also includes a list of terminals and connectors required for repairs. Let's study these points while watching a technician at work. First, let's look at the basic procedure for connecting two wires. For this, we prepare the necessary crimping tool, calipers, connecting sleeve, and silicone tape. First, we peel off about 10 millimeters of the insulation from the section that has been cut and twist each wire. Then we use the calipers to measure the diameter. Be careful not to squeeze the wire too hard with the calipers. Next, we derive the nominal size, that is, the area of the cross-section of the wire. To obtain the area, we multiply pi, which is 3.14, by the radius squared. In this case, it is about 0.85 square millimeters. This chart shows connecting sleeve sizes. The numbers along the top show the nominal size of one wire to be connected, while those along the left side show the nominal size of the other wire. When we look up the nominal sizes of the wires, which we just calculated, we find that we can use sleeves of 3 possible sizes. Because the wires are both 0.85 in this case, the intersection point is a triangle. For this reason, we should use the medium-sized sleeve, which is blue. We insert a wire into each end of the sleeve. We should insert the wires deeply enough that they do not come out and no bare wire is exposed. Next, we use the crimping tool to securely crimp the wires in the middle of the sleeve. Pull on both wires to confirm that they do not come out. Now, crimp both ends of the sleeve. For areas on the vehicle where water can easily enter, such as inside the engine compartment and in the doors, wind silicone tape around the splices also. This completes our explanation of how to connect wires. Next, let's talk about the terminals inside the connectors. In more recent cars, there is a double lock on terminals that makes it difficult for them to come out. But it also makes it more difficult to remove them. Let's look at a number of examples of how to unlock them. In removing the terminals, you can either make a special tool of this sort or use a tool with a pointed end. This conventional single lock type allows you to remove the terminal by unlocking a single lock. However, the terminal will not come out with this double lock type. With the double lock type, you first unlock the secondary lock like this. Then you unlock the primary lock in the same way as for the single lock type. If you look at the construction of this type of connector, you see that the terminal is locked by 2 locks, a primary lock and a secondary lock. The one we just removed was a female terminal. What about the male terminal? Here, too, we first unlock the secondary lock and then the primary lock. With this type of connector, the secondary lock looks like this. The construction is a little different from the previous one because a cover holds down the back of the terminal. With this type of connector, the secondary lock is unlocked like this. Let's see a cross-sectional view of this. This is the primary lock, and this is the secondary lock. This connector is used in the combination meter. The secondary lock on this type of connector is unlocked in this way. Up to now, we have looked at a number of different types of double lock connectors. Now, let's look at the waterproof connectors that are used in the engine compartment and other areas where water could enter. The parts with a different color are all secondary locks. With this type of connector, you first remove this terminal retainer. And then you unlock the primary lock. If you look inside, you see a structure in which the terminal retainer is retaining the pawl of the primary lock. There is also a similar type in which it is only necessary to slide the terminal retainer to one side. Furthermore, with the double lock type, the terminal cannot be inserted when the secondary lock is locked. You must first unlock the secondary lock and insert the terminal. Don't forget to lock it again when you're finished. Terminals are supplied with the wire attached. When replacing a terminal, you should connect the wire as we saw before. The thickness of the wire attached to each supplied terminal is unique. This means that other wires joining it may have a different thickness than existing wires. After confirming the nominal size, you should consult the chart we looked at before to determine the sleeve size. When carrying out repairs, be sure to work carefully to prevent breaking terminals and connectors and to prevent faulty wire connections. We have studied the basic techniques required for repairs in case of electrical problems. We have learned the routing of wire harnesses, how to read and use the EWD, and how to repair a wire harness. You should always use these techniques to carry out fast and reliable repairs of problems in electrical systems.